Hey, hello guys. It's another opportunity to learn, and in today's video we are going to be looking at the Simple Share project. The Simple Share project. By the way, already I have a video already on this Simple Share, all right? But for this we are going to be looking at the introduction and also look at certain concepts that are associated with the shell. So that is what we are going to be doing. So the big question, what is a shell? I believe that before we do anything, we have to understand what a shell is and of course how the shell works. What a shell is and how it works. So that is what we will look at briefly before we look at other concepts such as executable and other things that are also important to this particular project. So guys, what is a shell? I created a write-up for this, so let's look into that. Here we said a shell is a program that provides a CLI, which is command line interface, for interacting with an operating system. So basically, you cannot, as a user, you cannot interact directly with the operating system. I don't know if you understand that. For you to be able to interact with the operating system, you need more like an environment to be able to interact with the operating system. So the shell is what provides you with that environment to interact with the operating system. So you want to create, they expect us to create a miniature of the bash shell, because you should understand that we have what we call the command line, and there are different types. You have the bash command line or interpreter, command interpreter. You have Python. Python is a scripting language, but also has a command line. Then you have Perl, PowerShell. Of course, you have PowerShell here. Then you have Node.js, Send, SCD, and PHP. So and others. So basically, when we are talking about the shell, we are talking about an environment that helps us to interact with the operating system. That is basically what the shell is. That is basically what the shell is. Okay. So, having known that, in this project, like I said earlier, we have the bash shell. We have the bash shell. Which of course we are using, all right? If you can download Git bash and it gives you an environment to interact with your operating system. Other programming language, like I mentioned earlier, Python, it has its own shell, which is different from the bash shell. Then you have sed, SCD, which have its own shell with different commands. Then, like I said, Python. Then PHP is also a command line, and others. So they create an environment to interact with the operating system. So having said that, we are going to look through how the shell works. Since we have known what a shell is, then we are going to look through quickly how the shell works. Okay, how the shell works. So if you look at what we have here, I said when we enter a command, the shell interprets the command and passes it to the operating system for execution. Okay, then the operating system then carries out the requested action and return the result of the shell, then display the result on the screen. So basically, if you look through that, there are steps in what we just read. There are steps. So one of them is enter a command. So for you, if you open the shell, you have to enter a command. You have to enter a command. Enter a command. All right. Maybe I will not have to write this info again. So you have to enter a command. Then the shell will serve as an interpreter to interpret your command. Interpret your command. All right. Then passes it to the operating system for execution. So there's what we call command execution. Command exec. Command execution, and the operating system carries out the requested action and return the result of the shell. So after that, the action is carried out, and after execution, you get your result. All right, you get the result of whatever you have entered into the shell. Then display the result. So the shell basically runs commands, it runs scripts, command history, command completion, and environment variable. I may not have to go deep into this, but again, maybe subsequently I'll have to do another video on that. But know that the shell runs commands, it runs scripts, all right? Then it runs command history, command completion, helps in command history, command completion, and environment variable. So basically, that is just a simple explanation of how the shell works. All right, that's just a basic explanation of how the shell works. Okay, so. So after this, we are going to look through and take a deep dive by explaining some concept before we go into what the main thing we have. Okay? So in a shell, there's what we call prompt. A prompt, like you are seeing here. Okay, let me see this. I believe you can see this concept of blinking. That is basically how the shell works. All right. If you are in the shell environment, the shell have a prompt, and a prompt simply means that the command line wants you to enter a command into the shell. So basically, most time it's more like a $sign. Okay, it looks like this, and it expects you to enter a command. So if maybe you go there and say cd to change directory, then you hit enter, it's going to execute that command. All right, if you Go there to say ls, list files and directory. You click enter, it's going to execute that command. If you go there to say cat, you have a file called file1, you say cat file1 is going to list out the content of this very file. All right, if you go there to say exit, it's going to exit out of the shell, basically. All right, so these are called prompts, because when the shell opens up, it's going to expect the user to enter a command, and such are called what? Prompts. Such are called prompts. So let's look briefly into commands. Let's look briefly into commands. Okay. Basically, there are two basic types of commands. We have one, we have built-in commands, and we have the executable commands. Let me just leave it at exec, built-in command, and executable commands. Okay, so if we talk about built-in command, I believe you understood the explanation I was trying to give here. All right, talking about prompts that require a user to enter a command. So now we are talking about commands, and we said there are two basic types: built-in and executable command. So what are built-in command? What are built-in command? What are built-in command? Basically, built-in commands, they are commands that are part of the shell or command interpreter itself. Okay, more like they are innate to the shell. They are built into the shell. Okay, let me give this example. If you get a phone, maybe perhaps you got a new phone, there are certain applications that are innate to that phone. All right, they came with it. They are built inside it. Okay, they are built inside. So before you now think about downloading others that you will need, there are applications inside the phone before you start downloading. So those ones are built into the phone. I believe that makes some sense. Then for built-in commands, they are loaded into memory when the shell starts. The built-in commands, they are loaded into memory and waiting for them to be called. More like once a user enter a prompt that is a built-in command, they go all out and execute, and those commands are executed. And they are always available for use. Built-in command, one thing about built-in command is that they are always available for use. Okay, maybe I will give an illustration later on, but basically examples of built-in commands. Examples of built-in commands. What are those commands that are built-in? We have cd to change directory. Cd is a built-in command. We have echo. Echo is to display. Then we have exit. Of course, self-explanatory. We have pwd, print working directory. We have k to kill a process. We have alias and onset to onset an environment. So all of these and others are examples of built-in commands. Okay, I believe that is a little clear for understanding. Then we have the second one, which I had earlier listed but I've not explained. We have the executable command. We have the executable commands. So what are executable commands? Executable commands, unlike built-in commands, are separate programs or scripts that exist as separate files in the file system. I repeat that. They are commands. These commands are separate programs. They are programs. They are like files or programs. More like you have files in your system. You see, if I open this Windows, I have files in this system. All right. Some of them are innate to the system, while most of them are external to the system. So those ones that were not built in, those ones that are separate programs, separate files, they are called executable commands. So these commands are separate. They are scripts. They can be script or exist as separate files in the system. So they need to be loaded into memory when they are executed. So that is one thing about executable commands. They need to be loaded into memory once they are executed. But you remember what I said about built-in commands? Built-in commands, as soon as you are starting the shell, they are loaded into memory already. As soon as you start your shell, they are loaded into memory and waiting for you to enter any of them so that they can, give you the result after they show a prompt. You enter a command, then they output the result immediately. So what do you think? Built-in command, they are loaded into memory as soon as you start the shell. Executable commands, they are not loaded instantly, but when they are loaded into memory when they are executed. All right. Once a prompt is displayed and you enter a command, that is when they are loaded and they give you a result. So because built-in commands are loaded before you even call the command, enter the command, they are faster. I believe that makes sense, right? They have been loaded before you even enter them, so they are faster. While executable command, they are loaded when the files are executed. So examples, you have examples of executable command. We have cat. Cat helps us to display the content of a file. Then we have mkdir, make directory, which stands for make directory. Then we have cp, which stands for copy. Then mv, which stands for move. Then we have find, which stands for search for a particular file. So these are examples of executable commands. An executable command can be written in any programming language. I don't know if you understand that. They can be written in any programming language and can be made portable across different systems and shares. So that is why you can write your own commands, and such will be called executable command. So you can modify, you can create your own executable files or commands or scripts, as the case may be. So that is what they require us to build in this simple shell. So I believe that this is explanatory enough. All right, if you have any question regarding what I've explained so far, you can drop it in the comment section to this video. Okay, so let me clear here. I prepared a chart that will help us understand more of what we are talking about. All right, I was just explaining, but this chart will help us understand what we have been talking about. Okay, to help us understand some concepts we have meant earlier. So looking at this chart, you see that when you open your shell, as soon as you open your shell, okay, that is when processing or the programs will start running. Okay, then once it's open, it will require you to enter a command. That is what I represented here by input command. So it will require you to enter a command, that is input command. And like I explained earlier, that is what I called prompt. It will display a prompt. Don't worry, I'm going to show you very soon. More like, can you see this cursor blinking? That is a prompt waiting for me to enter a command. Same is true for the shell. Okay, so once you enter a command, it's going to do what we call tokenization. It's going to tokenize that command. Don't worry, I'm going to do some explanation on that. It's going to do what we call tokenize. It's going to tokenize that command. All right, it's going to tokenize that command, and we will be looking at the concept of tokenization. So if you enter a command, it's going to tokenize, and to tokenize means the shell will split the commands up into tokens. All right, it will split it up into tokens, and after splitting up, which is called tokenization, then it will pass a parser will take these tokens and use them to understand what has been written. Okay, so take for instance, you are writing a program. Say you enter the line such as int. Okay, let me say you enter car C equal A. All right, this is a line of code. Maybe another integer x equal 1. These are lines of code, okay, which a user or you the user have entered. So after entering this code, what will happen? They will be tokenized. They will be tokenized. How are they tokenized? They are split up into their units. They are more like split up into their units, and let me show you how that works. So you have different characters here. You have different commands here. So during tokenization, what happens? During tokenization, this first line will become it will read this as car. Okay, this is character, and that will be tokenized as character, as a command, as a separate command. Then you have C. This will be tokenized as a separate command. Then what else do we have here? We have this equality sign. Okay. Then what else do we have here? We have A. A will be tokenized. Then lastly, we also have something which is the semicolon. That is important too. So the process of splitting up, commands into their unit is called tokenization. It's called tokenization. So when you enter a command, it will be tokenized. Alright, into its different unit. So if you tokenize the second one, you have int, you have x, then you have the equality sign, and you have 1. Lastly, you have the semicolon. I believe you understand how this works now. So it's going to tokenize, split them up into their individual unit. After splitting, the next process that happened is called passing. So how does passing work? Passing involves breaking down a piece of code into, okay, after the tokenizer have tokenized the code, then a parser will take those tokens and use them to understand what is required to be done in the program. All right. You see, this is basically tokenization we explained earlier. So a parser, all right, we take those commands, all right, like the first one we have here. What is happening? The parser will look through it, okay, and we read, we have a statement here. After that, you understand that there is a statement. Then it looks through, okay, this is a declaration, all right? This is a character declaration, okay? This is a character declaration that I declared a character called C of C data type. I want the output to be of the C data type. Then I initialize it with the value of A. So that is basically what this statement is all about, and that is called passing. Passing. So a parser does that. Look at this second one. It will also look through this. After tokenizing, we tokenize here. It's going to pass this code, and It's going to pass this code, look through it, and understand how it works. So basically that is what is happening here. And if you look closely again, if the command we entered is exit, this will be executed. The shell, the process or the program will be terminated and it will end immediately. All right. If you enter exit, it's going to terminate. I'll demonstrate this. What I'm talking about is going to exit, terminate, and stop. The program will stop. But what if I didn't type exit? What if I did type exit? Then we go down. Is it a wildcard character? I believe you know what wildcard character is. Take for instance, I have this. Okay, first let me clear here. Basically, this is what we call wildcard. This asterisk sign. Okay. If I have asterisk.c, what do I mean by this? What do I mean by this? It means that I'm telling the system to take note of all the files that end with a .c extension. Okay, so that is what is called wildcard globally. It's a process of using wildcard character, such as the one I put in here, this asterisk and question mark. So basically, we have the asterisk, and the question mark as what? As wildcard, part of the wildcard globing process. So they have to match pattern in files or other strings, which is similar to the way that wildcard character are used in shell script. I believe that you have done we have the scripting, you have looked into that, and wildcard, they have to look into patterns. Okay, they look into patterns, and in those patterns they have to match files. So basically this will mean that I'm targeting all C files. Okay, so that is what is happening basically. So if it is a white character, do wildcard what? Globing. So I have explained that earlier. So it moves down and it carry out this operation called passing. All right, like I explained, it read the statement and interpret it. That is what passing is all about. Okay, and we have talked about tokenization that breaks it down, split it into different units. So I believe you are following gradually, and I believe we are. This will make a lot of sense when I demonstrate it. So here, after passing, then there's what we call it will enter into a process called piping or redirection. Piping or redirection. So what is piping all about? What is a pipe or piping? What is it all about? So that is the concept we are going to be looking at next. Okay? So piping, what is it about? Basically, a pipe is a simple way to connect two processes together in a unilized system. When we are talking about piping, we are connecting two processes together. So during this process, a pipe sends the output of one program to another program as input. So that is what I'm going to demonstrate here. It's more like a farmer that has a poultry farm, okay? The farmer has a poultry farm, he produces chicken. So the waste product of those chicken, they can act as manure. So when those products are released by the chicken, it takes them up, it gathers, and it keeps them, allow them to become to soften a bit and use them as manure in his crop farm. So that is what piping basically it's about. All right, you are connecting two processes, and the output of one process will serve as the input for another process. That is what is happening here. If you look closely, you observe that piping, if it is a piping or redirection, you see, pipe redirection, and the output. After this, we have gotten our output. Such output will be channeled as input for another program, another separate program. I call that program B. All right. Basically, this whole thing is A. This is a B. So piping or redirection help to the output generator will serve as input for another program. So basically, that's what happened. What if it is not piping? Piping, no. Then check if it is an executable or a built-in. If it is an executable or a built-in, I have taken my time to explain executable and built-in command. As a built-in, they are innate, they are native to the shell itself. Executable, they are files or programs that you and I can create in the shell or create our own executable files. So if it is not an executable, display error. If it is neither executable or built-in, display error. Then if it is one of these, execute the command and then display output, stop the program. So basically, this is just a basic explanation of what goes on in the shell, of what happens in the shell. So if it displays an error, then it's going to send the user back to the top. Send them back here to input a command. I believe you can see that. Send them back here to input a command. So this is just an illustration that will help us understand what is happening here. What is happening here. So I believe you are able to get something. If you have a question, you can drop it in the comment section to this video. All right. So having said all of this, I believe you have a basic idea of what we are talking about. So let us demonstrate. Let us demonstrate this. Are you ready? Let us see what is happening. And so if I come here, I created this project called Simple Shell. Okay. So in this simple shell, there are files. All right. There are files in that. And those files, they should have certain features. All right. Let me ls and we explain on. Okay. Let me just refresh this. I believe it's network issues. All right. So I'll just cd and do simple shell. First, let me do cd root, cd simple shell. All right, so if I list, so this is the files I have here. All right, these are the files I have here. So there are what's the project. For the project, what is expected, there are certain features to display a prompt and wait for the user to type a command. All right, and if an executable can't be found, print an error message and display the prompt. more like remember what we explained here earlier, all right? Printing an error. If an executable is no, if it is neither executable or built-in, print an error. If yes, execute command, and all of that. So that is what I'm reading out now. And handle errors. The shell should be able to handle errors. Then handle the end of life condition, which Control D, handle command line, and other features. So basically, what I'm going to do here, this file has been compiled, but I'm going to compile again so that you see that, okay, you see how the process is done. All right. Now we explain what is happening. So if I come here and try to compile this, doing with GCC command, GCC I use the white card .c, and I want to output that into a file we call shell. Okay, let's do something else. My file. So I'm using GCC, and what this white card, it means target all files that .c, then output them into a file called my file. So if I hit enter, I'll wait because it's compiling. So it's compiling. All right. So it's done compiling. So if I list the files, you see my file here. All right. It has been compiled. So either of this, I can enter that into my shell. All right. So if I do cd, to enter into the executable, I do /my file, which I just compiled. So if I hit enter, you see what is happening, guys. You see this $sign. I have left the batch shell and entered into the shell I created. Can you see that with this $sign? And this is where we talk about the prompt. All right, the prompt. It's waiting. This is a prompt waiting for the user to enter a command. All right. So if I enter a command ls, you see ls is recognized. It's going to list my files and directories. All right. You can see them. What if I enter a command such as give not found? So give is not a recognized command in the bash shell. What if I enter a command such as mkdir u? Basically, that worked because mkdir is a recognized command by bash. So if I list, you see that I have a directory called what? I have a directory called u. Look at it here. U. So basically, that is. So I can cd out of. Okay, I can cd into the u directory. All right. If I list file, it's empty, so I can cd out of that directory. All right. So you see, basically, this simple shell that has been built, it's working. And if I want to get out of this simple shell, I could just type the exit command, and you can see that I'm back to the bash shell. So basically, this is how the shell works. So I believe this video has helped you, at least give you an understanding of what is happening. I'll drop the link of the second video in the description. All right, you can go through the other one. Happy coding, happy creating your simple shell. See you in the next video.